Okay, so we're gonna do question 23 and question 24 from the AQA paper. And question 23 is asking me to prove that n plus 5 squared take away n plus 3 squared is equal to 4 bracket n plus 4. First thing you need to do to answer that question is write n plus 5 squared as n plus 5 bracket n plus 5 again. The squared means I'm multiplying the bracket by itself twice. Take away n plus 3 n plus 3. Now, the next job is to expand the double brackets. So I'm going to do n times n, which is equal to n squared, n times 5, which is equal to 5n, then 5 times n, which is another 5n, and then 5 times 5, which is 25. Now next we're going to put the minus, and before we expand the second bracket, I want you to be aware of this, and I want you to put them inside big brackets. Now I'm going to explain to you what that big bracket does later on. So open a squarish bracket and then do the same thing as what we've done before, multiply the n with the n here, so that gives us n squared, the n with the 3, which gives us 3n, the 3 times the n, which is another 3n, and the 3 times 3, which is 9. And now close your squarish brackets. So I'm going to rewrite the first part of my expression by collecting like terms. So in our case, we've got the 5n and the 5n, which is 10n, plus the 25 here. And now I'm going to try to deal with the second bracket. And let me explain to you what happens when you have a minus and then a squarish bracket like that. If you have a minus in front of a squarish bracket, then everything inside becomes the opposite. Well, the opposite operation. So here we had a plus n squared, and because I've got a minus in front, a minus and a plus will make a minus n squared. Next, I've got a plus 3n. Now because it's got a minus in front of the bracket, it's going to become a minus 3n, because minus and a plus makes a minus. And also you can think of it as having a invisible 1 there, and you're multiplying that minus invisible 1 with every single one of them, and that's why the sign is changing. Yeah, so let's continue. A minus times a plus makes a minus, and then here we have 3n, so we're going to write 3n here, and then again minus and a plus makes a minus, and then we've got 3n, and then a minus and a plus makes a minus, and then we've got a 9. And now what we can do is collect like terms. So let me just highlight the ones that are the same. So this one and those two are the same. This one and that one is the same. And finally that one and those two, that one is the same. So n squared take away n squared leaves me with nothing, so those two will cancel out. 10n take away 3n take away 3n, how much does that leave me with? Well, 10 take away 3 is 7, 7 take away 3 is 4n, and 25 take away 9 gives me 16. Now we're almost there. If you look at the 4n plus 16, we can see that it's got a common factor of 4. The highest number that goes into 4 and 16 is 4. So that's the highest common factor for both of them. I'm going to open up a bracket and I'm going to ask myself, 4 times what will give me 4n back? So in our case, we're missing the n. Then the next operation we have is a plus, so I'm going to put a plus here. And then 4 times what will give me 16? And I know for a fact it is 4 times 4. And as you can see here, this is the same thing as what we need right at the top. So therefore we've proved that n plus 5 squared take away n plus 3 squared is the same thing as 4 brackets n plus 4. And there's 3 marks there. Let's move on to question 24. Question 24 is about vectors, and what we need to do is prove something which is something that I'm going to comment on part B. Now, let's read the question. So it says in the diagram, PQ is equal to A plus 2B. So if I'm going from P to Q, the vector is A plus 2B. If I'm going from P to S, the vector is 2A. So P is here, S is there, so this vector here is 2S. Now notice with vectors, you have to be aware of the arrow. Okay, so if I'm going from P to S, the direction is upwards, so it's a plus 2A. Yeah? If I was going downwards, let's say I was going from S to P, then I would say my vector would be minus 2A because I'm going the opposite direction. But I'll explain that to you properly later as I'm doing the question. So, and finally the last one, it says Q to R, so Q to R is 1.5A take away B, just like it shows here. The first part of question 24A is to work out S to R. Now, if you look at S to R, so I'm just going to highlight that, you can see that there's no vectors there. So what do? Well, whenever you get a situation where you don't have a vector, ask yourself how you can go from S to R using another direction, or using another path. And you are restricted to taking a path just around the shape. So in our case, what we can do is go from S to P, P to Q, and Q to R. So we can say that if I want to go from S to R, I can go from S to P, so write down S to P, with an arrow at the top showing where you're starting from. So we're starting from S and we're going to P, plus, and you always write plus when you're writing it like that, P to Q, so I'm going to add that distance as well, that direction as well. Yeah, so that's why I've got the plus, and then plus Q to R. Yeah. All right, and finally, what I'm going to do is replace those letters with the vectors. So in our case, S to P is going to be minus 2A because it's in the opposite arrow, the opposite direction to P to S. As you can see, P to S was 2A, so the opposite one must be minus 2A. So I'm going to write minus 2A here. All right, next one, P to Q going in the same direction as the arrow, so we don't need to change the vector, so it stays as A plus 2B. And finally, Q to R, and again we're following the arrow, so we don't need to change anything on the vector. So this one here is 1.5 A take away B. And finally, you're going to tidy up the answer by collecting like terms, just like we do it with any expressions. So I've got the minus 2A, the A here, and 1.5A, which is the like terms or the things that we're going to add together. And we've got the 2B and the minus B here, which is something that we can add together and simplify. So let's take a look at the A's. Minus 2A plus A is equal to minus A, and plus 1.5A. How much does that leave me with? Well, I've got minus, so I'm left with half A. Alright, so the A's are done. Let's take a look at B. I've got 2B, take away B, so I'm left with just the B. And there's my answer. So that's giving me 2 points. Alright, finally, on part B it says what type of quadrilateral is PQRS. So you need to state what sort of shape this is. Now, if you look at the shape, you can obviously see that this is a trapezium because it's got two sets of parallel lines, okay, and it's got four sides, okay. So the answer is a trapezium. Right, not very good at spelling. So that's trapezium. All right, and the reason, well, the reason that you can give is by using the answer that you got from part A. On part A, we figured that that side here is half A plus B. And we also know that for a trapezium to exist, it needs to have a set of parallel lines. So that side here is parallel to that side there. Those two sides are parallel. Now, how can we prove that they are parallel though? How do we know? Well, like I said to you, we're going to look back at the answer that we got from part A, and we're going to compare it to the line PQ. And what you should notice, and there's a rule that you need to understand, is that if you've got two vectors going in the same direction, and one of them has is a multiple of another one, then they can be parallel. And the way to sort of explain that and describe is by saying, well, this vector here we can label it as, let's say, u, and that vector there we can call it v, and you can see that v is twice as big as u. So what you can say is v is 2 times u, yeah? And maybe we could put the arrow here so we know that we're talking about vectors, and you don't need to worry too much about the what the arrow means. Okay, it's just a way of describing vectors. Okay, so basically, just to take you through that one more time, how do we prove that these two lines are parallel? Well, we look at the two vectors for that line, and what you should notice is that one of them is twice as big as that one. Now, when you're doing your exam, it might not be twice as big, it might be something else, so you have to figure out how much bigger it is. So you can see that for that one, if I look at the B and the 2B here, 2B is twice as big as B, and here I had the half A, and here I've got A now, so that one is twice as big as that one. So therefore, I've called this overall vector as V, therefore I can say V is 2 times vector U, yeah? And this proves that the two lines are parallel, and that's all you need to write. Well, I hope that helps, and I'll see you soon, and best of luck for your exam. Bye.